The physics test after no, people do. They're all stressed about that.
Or C, right. Okay, so sorry I missed class on Thursday. Probably like the break. You have to talk loud. It's like whenever I get a big cold, my left ear clogs up. Okay, so let's look at the syllabus and just see where we are in the course. I regraded the exam redos, and Ben is just recording the grades, and then I can give them back to you today. So is everybody with me now? So the first section of course, first exam, second section, second exam. Sorry, I've written so much on this during the semester. Third section of the course, third exam, and that's the one, the redo that you're getting back. And a few of you got the exam late, so I see a redo up there. Okay, the fourth section of the course is friction truss, frames, and shear and bending moment diagrams. Trusses we've done already. Frames we've done already. Shear and bending moment diagrams we've done already, and I see that the solutions are the homework you turned in up there. The third one is friction, and that's the one I was going to teach on Thursday, so I asked you to watch the videos. I don't know if you watched them yet, but I just want to point out some highlights. So these are, friction isn't too bad, but people do get confused by friction, so that's why I sent you the email on these 5 items. So the first one says, remember, just as a reminder, 2D problems have 3 equations, right? Some of the forces in the x, some of the forces in the y, and some of the moments in the z. With friction problems, now there's a 4th equation, right? Because the frictional force is equal to mu times n, where mu is the coefficient of friction. So you now have 4 equations for each body. Does everybody get that? So if it's a friction problem and it's 2D, how many equations do you have? 4. Okay? And we don't do 3D friction problems. When you analyze friction, you always are looking at it in 2D. Number 2, you know this as well. The frictional force is parallel to the surface, just like we know in tension, it's away from the body in the direction of the rope. Weight, we know, is down, right? Normal is perpendicular to the surface towards the body, away from the surface. Frictional force is another one we know the direction of. It's parallel to the surface and it's in the opposite direction of motion. So first, whenever you do a friction problem, you first have to determine which direction the motion's in, and then you put the frictional force in the opposite direction. Bless you. If there is a possibility of motion in 2 directions, which is the first problem I did on the video, the block could be pulled up if the load's high, or it can slide down if the load is low. So you have to analyze it. If there's a possibility of motion in 2 directions, you need to analyze the problem both ways, which means first you analyze it with the motion going up and solve for the answer, and then you analyze it with motion going down. Malcolm?
So, if you consider friction to be a point force, what point would it be acting on?
That's a good question. It's always acting along the surface. It's not really at any point. But that's really interesting, because if you had to define frictional force, is it a point load or a distributed load? Certainly not a distributed load. It's a point load, but it's not really at a point. So it's interesting. Never thought about that.
Basically,
it's along the line.
Yeah, just have it along the surface.
Yeah.
Right.
Okay, yeah. 3. If mu is unknown, there's another unknown besides the unknown forces, right? In the tables, what do we check for on unknowns when we make up a table? Well, the first column of the table represents what? The forces and the moments that are present, right? And the next column represents what? The magnitude, and the next column represents the direction. So you're always looking for, is the magnitude unknown, is the direction unknown? And that's how you figure out your number of unknowns. But in a case where mu is given as an unknown, you now have another unknown. Got it? Is everybody awake? Stand up. Jump 7 times. Okay, so those of you who aren't jumping, I'm assuming you're awake. All right, 4. There is a potential of 2 different types of motion for friction problems. Sliding and tipping. They can happen at the same time. Likely one happens before the other. How many of you ever pulled something and figured you were making something slide, but you pulled it too high and it tipped on you? Not that fun. So you know you have to pull low, right? There's a potential of 2 different types of motion for friction, sliding or tipping. You can imagine trying, oh, wow, I was thinking the same thing. You can imagine trying to move a refrigerator. If you attach a rope around the refrigerator low, you will have it slide. If you attach the rope towards the top, you will make it tip. 5. If both motions can occur, you need to solve the problem 2 ways. First for sliding and then for tipping. So you can imagine if you have that rope around the refrigerator and you're solving for the force, you think we're doing kinetic or static friction? Which do you think? Static friction. So you're solving for static friction. So the load that you're calculating is, let's think about that. If you solve, do equilibrium equations in friction, and you get a value for P. If you get a value for P, what does that P mean? It's an equilibrium equation. It's static, even if there's a P of, let's say, 100 pounds. But if P is greater, what happens? It moves. It either slides or tips, depending on what we're analyzing, right? So if we have a rope around a refrigerator, and we sum up all the forces and the moments, and we solve for a P, and a P turns out to be 100 pounds, that means it's still in static equilibrium with P of 100 pounds, right? Because we used equilibrium equations. So that means if the load P is greater than 100 pounds, it's going to move, whether you're solving for tipping or for sliding. If it's under 100 pounds, what's going to happen? Nothing. It's going to stay still. So you could think of that 100 pounds as the maximum force for equilibrium. Does everybody get that? Because if you pull it at more than 100 pounds, it's going to slide or tip. But if it's less than 100 pounds, it's still not going to move. So the 100 pounds is the max for static equilibrium. Did everybody get that? Like sometimes it's confusing with max and minimum. But when you use static equilibrium equations, it's still static, it's not moving. It's not unless the force is greater than that. Okay, when you analyze for tipping, take the sum of the moments about the point of tipping. So in this particular case, when I tip it, it's tipping on the wheels right here. If I just go about to tip it, where is the normal? There are 2 sets of wheels here. Where's the normal? The normal is where it's being tipped, because the normal is from the surface, right? So when I go to tip it, and I lift this cart off the wheels, is there a normal there anymore? No. Right? So once you start analyzing, when you analyze for tipping, you take the sum of the moments about the point of tipping, and it's important to know that when tipping is just about to occur, the normal only exists at the point of tipping. There's no normal in the center anymore. Okay? So if I do a sum of the moments about the point that it's tipping, can I calculate the normal? Let me say that again. If I am doing a sum of the moments, if I'm doing the sum of the moments about where it tips, can I solve for the normal?
No.
Why not? Because the normal is right at the point of tipping. Okay? So normally when we have something on the ground, we have this on the surface, we always put the normal in the middle. But if I'm going to tip it, the normal is right here at this point. The normal is no longer in the center. So when you analyze for a friction problem for tipping, you move the normal from the center where we usually have it, and you put it at the point of tipping. And if you do a sum of moment about that point, you can't solve for the normal, and usually you don't need the normal anyway. You want to know the load that's being applied. Has anybody started the friction problem yet? Has anybody watched the friction videos yet? No? A little bit. Okay, good. Okay, great. So at least I'm giving you some background before you do. Last one. For the refrigerator example above, where the rope is pulling the refrigerator from above its center of gravity, you need to solve for the tension of the rope both ways for sliding and tipping. You will get two values of T. So I said P, but if you have a rope around a refrigerator and and we're calling it tension because it's a rope. If you solve for T up here for tipping and you solve for T down here for sliding, you're going to get two values of T. Why are you going to get two values of T? Making sure you're paying attention. Why are you going to get two values of T?
Tipping versus sliding.
Right, because you're going to solve the equilibrium equations for tipping and sliding. If the smaller value, oh, look at that. You can tell I was kind of added it a little. It should be the same variable. If the smaller value of T is during tipping, then you have learned that tipping happens first. Okay? So I kind of gave you highlights of the key things of friction that people have questions on or have confusion. And now make sure you watch the friction videos and then do the homework. And let's check, what does the homework do for friction? The 4th, which is Thursday. Okay, let's go back to this. So these last 4 topics, again, we've already done trusses and frames. You have your homework back. You did shear and bending moment today. And Ben, maybe I can have you give this back to everybody. I couldn't post the solutions to the homework when I'm at home. I could only do it at school. So I emailed you all the solutions, but I will make sure that today I post the solutions to the website. Okay, so the only one you have left is friction. I mentioned to you on when I'd like to have the friction exam, but I would prefer actually to take the exam out of class time so that we have one extra class to do material. So there are 2 times that the engineering lab is open, is Wednesday evenings from 6 to 9 and also Thursday 6 to 9. So what I'd like to do right now is just pass this around the room and you check off which one works for you. And if neither one does, then write a little note for me here. I realize that some of you take it at the Proctor Center, so you can just write Proctor Center on it. Okay? I hope everybody's okay with that. I really feel like I'd rather have the class time. In the past for statics, I used to have only 3 exams. 1, and then I combine these into 2 and this into 3. But this year I did it separately, just so that you would have less material on the exam. So I would like to do this, so sorry if you're not happy with that. Yeah.
Can you tell us a little about the finals?
Yeah, I'm trying to get, the beginning of this is all summary. Okay, so we only have 2 more topics left, and we're going to do center of mass, gravity, and centroids. And you've done that already with a single object using integration. We're going to do looking at calculating it for parts, because as engineers, when we design things, we're always dealing with a bunch of parts together, and we really need to know where their center of mass is, or their center of gravity, or their centroid of area or volume. So we're going to cover that today. And then on Thursday, we're going to look at moment of area and the second moment of mass, which is called the moment of inertia. Okay. All right, so let's go back. I did send you an email regarding the workshops. I'm not going to be able to pull that up, I don't believe. Does anybody remember what I sent about the workshops? They count as extra credit towards what? The homework workshop grades. So for instance, I don't know if I gave you an example, but let's just say if you take all the homeworks and all the workshops, and let's say there's 20 of them. Normally what I would do is I would add up all the grades and then divide by 20, and that would be your average homework and workshop grade. One thing. But what I'm going to do in this case is I'm going to add up all 20, and then I'm going to add all the extra ones that you do, and I gave you a choice of like 5 or 6, and I'm still going to divide by 20. So you have the option of getting over 100% as an average for your homework and your workshop grades. Everybody get that? Right, so I'm going to normally add 20 up, divide by 20 to get an average. I'm adding those 20 plus I'm going to add the extra ones and still divide by 20. So how does that impact you? If you look at the grading, 15% of your homework is, 15% of your grades is your homework and your workshop. If you look on the workshops, it says that they're counted as a homework grade. So I'm gonna, the homework and workshop grade is 15%. I probably should write workshop grade. Okay, let's see what else. Okay, final exam. So your final exam will be administered during the scheduled final exam period, which is Tuesday, May 16th from 7 to 10. Or, that's when it's scheduled, 7 to 10, but I know it's an ungodly time. So I need to find out if anybody is not available or available. So what I want you to do is I want you to, after today, look at your final exam schedule and see if you have a 10 to 1 free on Tuesday or Thursday. Because if you're all free then, let's take it at 10 instead of at 7. But you need to look at your exam schedules, okay? So we'll regroup on Thursday. Will everybody look before Thursday? Yep.
Deal.
Okay. This is a cumulative exam that it covers all the material presented in class. And you noticed in statics, it's all cumulative. What was the first topic we learned? Components, solving for components, 2D and 3D. We've been using it the whole semester. Next thing we did was resultants, sum of the forces. They equal the value. Well, now we sum them up and they equal 0. Then we found moments, how to calculate moments, and we got a value. Now we're summing up the moments and they're equal to 0. Everything you learned, it's all cumulative. Everything is cumulative. Okay, so the final is cumulative. A one-sided 8 by 11 sheet of paper can be brought in as a cheat sheet. Into the exam, you will need a half-sheet blue-green Scantron. So it's a half a sheet. It's kind of like a little bit more aqua than this, aqua. Kind of more like, Yvette, could you hold up your water bottle? It's kind of like actually in between that, it's like that color. Okay? So what does that mean? It's actually a multiple choice exam. As an engineer, all of you will take the fundamentals in engineering exam. It's called the FE exam. It's also referred to as the engineering and training exam. And it's an 8-hour exam, multiple choice, that covers all the material that you learned in your first 3 years of school. Chemistry, physics, computer science, materials, circuits, statics, graphics, junior level, fluids, thermodynamics, engineering economy. What have I left out? Surveying, whatever I left out. So it covers all that material, and that is the first exam that you want to take and you pass. And if you fail it, you take it again. If you fail it, you take it again. If you fail it, you take it again. You keep taking it until you pass it. And if it covers freshman, sophomore, and junior level work, when do you think you take it? Senior year. Those of you who took Engineering 5 and those of you who took surveying already know about it. All civil engineers may take it. So I cover it in Engineering 5 or survey. Those of you who haven't taken those classes may not have heard about it yet. But you'll find out about it when you go to transfer. Everyone in your senior year will be taking it. All your friends will be taking it. Everybody will be sitting down and taking it together. It's 4 hours in the morning, you get an hour for lunch, 4 hours in the afternoon, it's all multiple choice. You want to take it, so you pass it. The importance of this FE exam is that if you decide you want to be a licensed engineer, you need to pass that test. And then, if you want to be a licensed engineer, eventually you'll have to take another test after you start working as an engineer for a few years. Now, you don't know if you want to be licensed. All of you who are civil, environmental, structural, or architectural will get licensed, because that's what you have to do. The rest of you may or may not get licensed. Who knows? And you never really know. 20 years from now, you might want to work for yourself, own your own company. You want to do a government job. Who knows? You have to be licensed. So you may never in your career ever need your license. But if you own your own company or you work for an employer that wants to see licensed engineers, you might get licensed. So you want to take that FE exam in your senior year and keep taking it until you pass it. Because you never, ever want to take that exam 10 or 20 years outside of school, because you will not remember everything you learned in school. The second exam is specific to your major. So if you're mechanical engineering, you would take the mechanical engineering PE exam. If you're environmental, she's going to take the environmental PE exam, or the electrical engineering, or the civil engineering. And that you'll know, because you'll be working as that type of engineer. You know what they do. You could pass that test. But this FE exam that includes stuff from your freshman year, you will not be using as an engineer. So you need to make sure you take it and you pass that test. Everybody gets it? What's the name of the test? FE exam, and then you're considered an engineer in training. Okay? I would suggest in your senior year, you sit and you take the test cold. Don't even study. If you pass, you never have to study for it. If you fail, then study. About 80% of you will pass on the first try. Yeah.
Is there a score?
Yeah, it's a score, but it's kind of, they average it, because if you get a 70, you pass. But what they do is they move it around, so.
But it's not like the AT where, you know, like, for example, it's like 900.
Well, it's like a teacher curving a grade on a test. 70 is passing. But if they decide to take all the 60s and move them up to 70, and you get a 70, you pass. Okay, so you need to, have some practice doing multiple choice. We tend to not do too much multiple choice, right? So that's so in materials, I think Carl gave a multiple choice final. Who took materials? Did he give a multiple choice?
Yeah, part of it.
Yeah, okay. So in materials, in statics, in surveying, we give multiple choice finals. Plus, it's quicker to grade, so that you can get your final exam grade, your final grades back. So that's what it is. What is an example of a statics problem? You'll have a beam, and you'll have all these forces on it, and here's point A, and there's an AX and an AY. And there's another unknown here, normal, and it says find the normal. The This is given, this number is given, this number is given, this number is given. Here there's a pin, here there's a roller, you know there's an x, ax, and ay, and you know a normal, and it says find the normal. So, do you have to do the given? No. Find? No. Table? No. Components? No. So all you need to do is what? Sum of the moments about this point, and you get the normal. So it's a multiple choice question that's not a full, so the goal in this class is for you to be able to approach a statics problem as an engineer, analyzing the problem fully, looking at how many unknowns, and calculating the values, but the whole setup is very important. Your presentation is very important in engineering. On the FE exam, they just want to know if you know how to solve one statics problem with one equation.
The exam is usually like last semester, or
The FE exam is offered in twice a year in October and April. So you could take it in either time. You could take it in October and then hopefully get your result before you have to apply for April if you fail. So to give you some practice on statics multiple choice, if you go in the packet and you go towards the end, there's a whole boatload of problems. So beginning on page 54, there's practice, and the problem is there, and then the solution is there as well. So here's some practice. If you want more practice, there are FE exams and solution exams in the library that you can look at too. I pulled the final exam. I'm probably going to tweak it, but I'm pulling problems from past FE exams. Okay, questions about the final? Okay, yeah.
So our fourth exam is the week before the final.
Say it again?
Our fourth exam
Yes,
is the week
yeah.
before.
This is the second to last week of classes.
And next week is the last week of class.
You have to talk louder, I'm
So
sorry.
next week is the last week of actual classes. And
Yeah, it's we started earlier in January this year, so we're finishing early. I don't know, good or bad. I don't know, I think it's a little early. Maybe you're happy. I'd probably rather start it later in January. Everybody has their own opinion. Okay, Charlie, Gracie, David.
So the Thursday quiz, is that going to be on share? Or
Okay,
can I
so
ask that
quizzes
question?
are only on Tuesday, and since I didn't talk to you about quizzes, there's no quiz today.
Oh. Well, I thought you said there was, okay, never mind.
Yeah.
Tuesday.
Friction exam, but you meant the whole section.
Yeah.
Is the statics project still due on Tuesday?
No, so let's look at the other email I sent you, David.
I was just wondering, around how many questions were there multiple?
There are 20 questions, so it's not too much. On the statics, it's 20, the final is 20 questions, so that's 2.5. Is that right?
No.
So that's
5 points per question.
1% of the day per
I
question.
wonder if it's 40 then. I don't think it's 40. So it's 20 questions would be 5 points each. Let me look it up, I can't remember. I think it's only 20, because I wanted to make sure you had enough time. I think it's only 20 questions. No, if they're it's 100 out of 100. So if there are 20 questions, it's 5 points each.
I was just basing the finals for 20%.
No, I don't know what the teachers do with all these weird points. I mean, everything's out of 100 for me. So
Well, we're
you know,
just
like you
talking,
get 180 points for something. I don't know how they do the math. Yeah.
Oh, I thought we was just talking about because the final exam is worth 20%
Yeah.
of the grade, so it's
So I mean, you could think
Each
of it
question's
like that if
1% of
you
your
want,
grade.
but then it's but 20% of that. So okay, so David, what was your question?
yeah, you answered it.
Okay, yours is about this. Okay, so So, so in the email I sent you, I had said that, well, okay, the design project sheet has everything, the presentations and everything due a week from today. And then I sent you an email saying, oh, our 4th exam would be Tuesday. I'm fine with the project being due Thursday, the last day of class. So a week from this Thursday is when we'll go over the projects. So that means we have today and Tuesday and Thursday. I mean, today, Thursday and Tuesday. So yeah, most recently I said that the project wasn't due until the last day of class on Thursday, and that I want to honor still, even if the exam isn't Tuesday. Okay. So what are we covering today? We're doing centroids and center of mass, so that means it's due a week from today. So that would be the 9th. And then this would be due on the 11th. And please note, make sure you're taking this out. I crossed 3 problems out here. Everybody has this? So homework 17 is due a week from today. Homework 18 is due a week from this Thursday. And here is the last 3 problems we're not going to do. Okay? Okay, any other questions with about the course? Okay. Let's take a look. We're not going to do the whole problem, but I want to take a look at something for a minute. I'll let everybody get up and stretch.
What?
So I want to review distributed loads for a minute. Okay, any other shear and bending moment diagram homework? Did everybody get one of these sheets? We'll pass it down. Who else didn't get one? Anybody else need one of these? Okay. Eddie, you have one? Okay. So if you have a distributed load problem, how do you handle it? What do you do to the distributed load? You turn it into point loads, right? So how would you divide this if this is a rectangle and a triangle?
2 parts.
divided into two parts. So this is 1 and this is 2, right? So if I were to draw this down, I could say, here's F1, right? And what is F1 equal to? The area of 1, right? And then where is F2? Right here. Is equal to the area of 2, right? And let's say this is L1 and this is L2. This right here is going to be L1. And then what is this right here? 1/3 of L. 1/3 of L2.
It should be half.
Thank you. And this is still point A. Can I simplify it even more? Can I simplify this problem even more? I started out with 2 distributed loads. I converted it to 2 forces. Could I convert it to 1 force? What kind of problem is that? Equivalent system, which type? It could be a force moment or a force location, but let's say I want the resultant force to be here at some perpendicular distance. What is this problem? It's a force location problem. A force location equivalent system problem. Right? So I took something with 2 distributed loads, I converted it to point load, 2 point loads, and then created it to 1 point load. How did I find this point load?
Some of the forces in the Y.
Okay, so R, this is equal to the sum of the forces in the Y. Okay, and then how did I find the perpendicular distance?
Take the moment about A and divide
Sum
that
of the
by
moments about A and divided by
FR.
the sum of the forces in the Y. So I looked at point A, I summed up the forces times the distances, figured out the moment, and then divided it by the resultant force, and I found the distance. Okay, so now, I'm your origin over here. And I want to find the center of your weight of this whole classroom. So look around the classroom and locate where I should be to be in the center.
Right around.
So is this a good spot? No, I should probably be over here somewhere. Let's see, there's 4 of you there, 3 about the same, assuming about the same weight, maybe 6, 5, maybe like right here. How did you figure that out? No, you did spatial arrangements in your head. You didn't just guess.
An educated guess.
But you did spatial arrangements. So you looked at the distances. So if I wanted to do it mathematically, let's say this is my x-axis and this is my y-axis. Along my x, how can I calculate the exact location of the center of you? What would I do? Think about it. It's very similar to this. We're looking at weights and we're looking at distances. What do? I want to find the location along the x-axis where the green center is.
Measure the full 5 by 2.
Say it again.
And we're assuming like equal mass throughout everything.
No, let's say everybody has their own weight. Okay, so I would take the weight of Daniel and I'd multiply it by 6 inches. Or let's say ½ a foot. I would take the weight of Gabby and I would multiply it by the distance. Take the weight of Heather, multiply it by the distance. Take every one of you, take your weight and multiply it by the distance. And then what would I do? How do I average them?
By the sum of our weight.
Divided by the sum of your weights. How about in this direction? Same thing?
Yep.
Weight of Daniel, 2 feet. Weight of Eddie, 6 feet. Weight of David, 10.5 feet, right? And do it for everyone and then divide by the sum. So in essence, in order to find the location X along here, I took the sum of the weights of each of you times the X distances. And divided by what? Sum of all the weights. Does everybody agree? And then the same thing with the Y. And I'm not going to write it as mathematical now. I'm going to do the sum of the weights times the distances divided by the sum of the weights. And I could find the location. Isn't that very similar to this? Right? What is this really? What is the sum of the moments? It's sum of the forces times the distances divided by the sum of the forces. It's really similar. So we're going to find that we're going to do, this is the kind of stuff we're going to be doing because we're looking at composite bodies. In this example in this room, there's a composite body of, I think you're about 30 or so today. When I did some of the moments, I did it about point A, right? You guys, when I took the sum of the forces and multiplied it by the distances, I had to have a reference point. It's the same thing with this problem. If this is my x-axis and this is my y, here's my origin. You did some of the forces, your weights, times the distances, and the distances were all measured from the origin. So let's look at a problem. Before we do that, though, there are a few different critical components. There's centroid, 2D. There's centroid, 3D. There's center of mass, and there's center of gravity. So what's the difference between these and these? You might say, oh, it's all the same. The center is always going to be the same. In many cases it is. But what's the difference? What does the term centroid mean that center of mass and center of gravity doesn't mean? In other words, what is the critical component I'm thinking of in centroid? What is centroid about? Okay, let's do this. What do you think you're dealing with when you're dealing with center of mass?
Mass.
Good.
Oh,
When you deal with center of gravity, it's
gravity.
not gravity. Weight.
Come on, man.
Okay, so now we're looking at this and we notice that center of mass is really a function of its mass. Right? Center of gravity has to do with weight, so it's mass times g. But these two centroids have nothing to do with mass and weight. What does it have to do with?
Area.
Okay, their geometry. And if it's 2D, it is area. And if it's 3D, it's volume. Oh, thanks. Malcolm.
So the centroids are only the same as the center of mass if it is of uniform density.
Yeah, you guys told me this.
No.
Physics. It has something to do with space or non-space and
I'm a lady.
in our situation, in the real world, well, what's the real world? Is space the real world? No.
No.
Where are our structures? Well, our structures could be in space, right? There's a woman up there at the International Space Station right now, but we're talking about right here. It's all the same as long as we're dealing with homogeneous material. But at different altitudes or space or whatever, we're not going there. Okay, so when we did this problem, what were you finding? Were you finding the center of the area, center of the volume, center of mass, or center of gravity? What did you use in the calculation? Weight. So what were you finding?
Center of gravity.
Center of gravity. If we took our mass, would we have found the same answer? Yeah, because it winds up to be the same. But in this particular class example, what were we doing? We were trying to find the distance, and what did we do? We summed up the weight times the distances and divided by what? The sum of the weights.